All right, today we're going to do a full teardown of the most incredible engine you will ever own, your heart. Seriously, it's a masterpiece of mechanical and electrical engineering, and we're about to see exactly what makes it tick.
First off, just take a look at this thing. It weighs only about 300 grams. That's roughly the size of your fist, and yet this muscle is an absolute powerhouse. It's working day in and day out without a single break to keep every last one of your cells alive.
And just how hard is it working? Well, even when you're just sitting there chilling out, your heart is pumping a staggering 5 liters of blood every single minute. That's pretty much all the blood in your body. But get this, when you exercise, that output can jump up 4 times. Just try to imagine that kind of workload.
So here's how we're going to break it all down. First, we'll meet the engine, get its basic specs. Then, we'll dive into its mechanical design, followed by the electrical symphony that keeps it all running. After that, we'll see what happens when the fuel lines get clogged. And finally, we'll talk about how you can tune this thing up for a long, healthy life.
Okay, first up, the basics. Your heart is tucked away right between your lungs in a little space called the mediastinum. Its main job, it's the body's ultimate delivery service. It pumps blood to all your tissues, making sure they get the oxygen and nutrients they need to keep you going.
Now, for the really cool part, its design. Let's think of the heart kind of like a house. It's got 4 rooms and some really smart one-way doors. This setup is absolutely crucial for making sure blood flows in one direction and one direction only.
So the 2 upstairs rooms are the atria. These are the receiving chambers, where all the blood returning to the heart gets collected. Then downstairs, you've got the 2 ventricles. These are the powerhouses, the thick-walled pumping chambers that do all the heavy lifting and force blood out to the body.
And this brings us to the actual path the blood takes, which is this brilliant 2-pump system. So step 1, old, used blood from the body comes into the right side of the heart. Step 2, the right side gives it a big push over to the lungs to get a fresh tank of oxygen. Step 3, that new oxygen-rich blood comes back into the left side. And finally, step 4, the super powerful left heart pumps that fresh blood out to your entire body. It's this beautiful, efficient loop.
The whole rhythm of this pump comes down to 2 phases. You've got systole, that's the squeeze, when the heart contracts and pushes blood out. And then you've got diastole, that's the relaxation part, when the chambers open up and fill with blood for the next beat. Squeeze, relax, systole, diastole. That lub-dub, that's the sound of your heart at work.
Now, how powerful that pump is depends on 3 key things. First is preload. Think of it like stretching a slingshot. The more the heart muscle stretches before it pumps, the more forceful that pump's going to be. Next is afterload. This is the resistance the heart has to push against. It's like trying to pump water through a pinched hose. It's a lot harder. And finally, there's contractility. That's just the engine's raw horsepower, the natural built-in strength of the muscle squeeze.
So we know how the heart pumps, but what tells the muscle when to pump? That brings us to the electrical system. It's like this incredible symphony going on inside your chest, the engine's onboard computer that keeps everything perfectly in time.
And take a look at this. This shows you the whole system. What you're looking at is a specialized network of cells that create and send tiny electrical signals across the heart muscle, telling it exactly when to contract. It's an amazing, perfectly organized chain of command.
And the conductor of this whole symphony? It's this little guy, the SA node, or sinoatrial node. This is the heart's natural pacemaker. It just sits up there in the right atrium and fires off between 60 and 100 electrical sparks every single minute, setting the rhythm for your entire life.
And here's the path that signal takes. It's like a lightning-fast chain reaction. It starts at the boss, the SA node. Then it hits the AV node, which acts like a little delay switch, just to give the ventricles a second to fill up with blood. From there, it zips down the bundle of His, splits into the bundle branches, and then spreads all through the Purkinje fibers, triggering that big, powerful squeeze from the ventricles.
So this is all happening inside your body, totally hidden from view. Which raises the question, right? How in the world can we actually see this electrical signal to know if everything's working the way it should?
Well, we use an electrocardiogram, an ECG, and that famous squiggly line is actually pretty easy to decode. That first little bump, the P wave, that's the atria squeezing. Then the big spike, the QRS complex, that's the powerful ventricle squeezing. And that last little bump, the T wave, that's just the ventricles resetting for the next beat. So it's atrial squeeze, ventricle, and ventricle reset. Simple as that.
Okay, so for this incredible engine to work, it needs its own fuel supply, right? And that brings us to a really important topic. What happens when those fuel lines get clogged? Let's talk about one of the most common heart problems out there, coronary artery disease.
The root cause of this disease is something called atherosclerosis. You've probably heard of it. It's basically a buildup of gunk, fatty plaques, inside the coronary arteries. Those are the little vessels that feed the heart muscle itself. This buildup makes the arteries narrow, and it restricts blood flow, kind of like a nasty clog in a pipe. Now, some of the risks for this are, well, they're just out of your hands. Things like your family's health history, getting older, your gender, your race, these can all play a role, and there's not much you can do about them.
But here's the good news. There are a ton of really powerful risk factors that you absolutely can control. We're talking about high cholesterol, smoking, high blood pressure, diabetes, obesity, and not getting enough exercise. These are all things that you can manage through your lifestyle choices.
And speaking of cholesterol, it's not all bad. There's a reason we call HDL good cholesterol. Think of it like a garbage truck for your arteries. Our source material puts it perfectly. It, quote, transports other lipoproteins such as LDL to the liver, where they can be degraded and excreted. So basically, it grabs the bad stuff and hauls it away. A high HDL level is a great thing to have.
All right, let's get to our final section, the tune-up. How can we actively take care of this incredible engine and make sure it runs smoothly for a long, long time?
Well, a huge piece of the puzzle is diet. The evidence is really strong here. The source material specifically calls out the Mediterranean diet, saying it's reported to reduce mortality from cardiovascular disease. What you eat has a direct, powerful impact on your engine's performance. It's that simple. And if you want some concrete numbers to aim for, here's what a healthy lipid profile generally looks like. You want your total cholesterol to be under 200, your LDL, that's the bad stuff, to be under 130, and your HDL, the good stuff, to be above 30. These are fantastic numbers to know and to talk about with your doctor.
So, let's end with this thought. Over an average life, your heart is going to beat almost 3 billion times. It is, without a doubt, the most reliable, hardworking, and vital piece of machinery you will ever own. So the real question is, now that you know how it works and what it needs, what are you going to do today to protect it?